Welcome to section 1.3, slope of a line. So we were graphing and we saw that linear equations have the graph of a line. We're going to talk about how we can describe a line. One of the ways we describe a line is by its steepness. So let's look at a couple of examples of a line. So let's talk about this line right here versus this line. All right, and we can say, well, we learned some terms from section 1.1. This one is, they're both increasing for sure, but this one is increasing slower and this one is increasing faster, right? And so we would say that this is less steep and we would say this line is more steep. One way we can do that, we're going to break that down a little bit in this section, and we're going to kind of put these lines on a grid. And we can talk about a line by the change. So for instance, we can consider the horizontal change, how much this line changes horizontally compared to how much it changes vertically. And we can see just visually that we have a long horizontal change and a smaller vertical change. And we see that this line is not as steep. And let's go over here to our steeper line. Here we have a smaller horizontal change compared to its larger vertical change. Change as in distance, right? How long it is. And then this line is more steep because we have a smaller vertical change compared to a longer, horizontal change is small, the vertical change is larger. All right, so again, we're comparing the vertical change and the horizontal change. And that's how we're getting this measure of steepness. One way to compare is to look at a ratio. So that's what we're going to be doing in section 1.3, the vertical change compared to the horizontal change. And this gives us a measure of steepness. But we're not going to call it a measure of steepness. A measure of steepness in mathematical terms is called the slope. All right, and that's what we have here. Slope is a measure of steepness. Slope is a measure of steepness. Let's develop our formula for slope and see how we derive it. Let's take two ordered pairs . And we want to eventually develop a formula, so we're going to just give them kind of generic names. We'll call the first ordered pair x1, y1, the second ordered pair x2, y2. Let's draw our line through these 2 points. And again, we're going to look at that ratio of vertical change to horizontal change. And really when we say change, that's just a distance. So we're going to be definitely using our distance formula. Okay, so there you go. If this were on an xy axis, let's just kind of impose that right here. This would be x1, and then this would be x2. And so x1 to x2, it's the distance formula. Distance is subtraction. All right, so there you go. So that horizontal change is x2 minus x1. We can do something similar for the vertical change. This is going to be y1. This is going to be y2. All right, so again, this is going to be your vertical change, and we can use the distance formula, which is subtraction. So the distance between y2 and y1 is y2 minus y1. All right, and again, we want to look at that ratio, the vertical change over the horizontal change. All right, let me get my over sign in there. And so this is our slope. This is going to be our slope formula. And then the symbol we use for slope, if you remember, is m. All right, so let's write all of this out. This is our conclusion. Let's write it out down below. The slope of the line through the points x1, y1 and x2, y2 is the following. M is the slope formula. Y2 minus y1 on the top. And then let's make sure if y2 is going first, we have to start with the same corresponding coordinate on the bottom. All right, so a couple of notes. Common mistakes I see is to forget that y goes on top. So let's remember y coordinates are always on top. And the second thing you check when you guys are doing your formula is that your ordered pairs match up. So you have x2, y2 in the front, and that means x1, y1 has to be second. So your ordered pairs have to match up. Like that. All right, so use the same ordered pair as the starting point. Let's practice. We're going to find the slope of the line that contains the point 2, 3, and 5, 1. Okay, so m is our slope is equal to the following. All right, and it doesn't matter what your starting point is, it just has to be consistent. All right, so for instance, we know y has to be on top. Let's have 5, 1 be our starting point. So we could have y minus 3. That's the change in y. Same starting point, and now we take the difference of the x's, 5 minus 2. All right, so 1 minus 3 is negative 2. 5 minus 2 is 3. Let's bring that negative to the outside, so we're looking at negative 2/3. All right, and again, let me do the same problem. This is kind of like a bonus round. If we chose 2, 3 to be our starting point, all right, and so we would do 3 minus 1, and we would do 2 minus 5. So everything's backwards. All right, and I'm doing this because it doesn't matter what point we start with. It just has to be consistent. All right, and it has to line up. Okay, so again, in both cases our y is on the top, x on the bottom. Our ordered pairs match up. This is the point 5, 1. This is the point 2, 3. This is the point 2, 3. This is the point 5, 1. All right, and there you go. Okay, so the only thing we wouldn't want to do is combine them. So for instance, if you did 3 minus 1 divided by 5 minus 2, it would be incorrect. You would actually get 2 over 3. You would get positive 2/3, and the answer is negative 2/3. So we have to keep it consistent. Okay, let's consider horizontal and vertical lines, and let's consider their slopes. So we'll consider a horizontal line and we'll consider a vertical line. So remember, a horizontal line is y is equal to some constant, like 5. Vertical line is x is equal to some constant, like negative 2. All right, so if we consider the slope, we know it's the vertical change. We can do change in y over change in x. All right, well, what is the change in y? How is y changing? Well, remember, with a horizontal line, y does not change. Y never changes. Y is 0. And then the change in x is whatever. It's just x2 minus y1. The x's are changing. So in this case, for a horizontal line, the slope is always 0 for a horizontal line. Let's consider the vertical line. We'll do the same argument. So again, it's change in y over change in x. Well, the y's are changing because we are moving up and down. So it's whatever that change is divided by the change of x. Well, x isn't changing. It's always the same value. We're just going up and down. We're not moving left and right. So we have a 0 in the denominator. That's not good. That's a big no-no. So in this case, we would say undefined slope. All right, and I want to make this clarity. Make sure if I ask you what the slope of a vertical line is, or I ask you what the slope of a horizontal line is, don't ever say no slope, because I don't know what that means. Either say m is 0 or m is undefined. Okay. Continuing on, parallel and perpendicular lines. Parallel lines never intersect. They run right next to each other forever and ever, never intersect. And another way of kind of visualizing that, it's because that they have the same steepness. They have the same steepness. That's why they never intersect. So if we have the slope of these lines, m1 and m2, if they're parallel, they have the same slope. That's why they never intersect. It's the same steepness. Parallel lines have the same slope. Or m1 equals m2. All right, and then we have perpendicular lines. Perpendicular lines meet at a 90-degree angle. And perpendicular lines, we can think of the slopes as being opposites, right? That's why they're meeting at that 90-degree angle. So perpendicular lines have slopes that are opposites Another way of saying that is whose product is -1. Whew. So negative reciprocals is what we call that. So just to do a quick example, because that is a little bit confusing. Let's say we have a slope of -4. Then the perpendicular slope, we're going to flip the 4 and do the opposite sign. So it would be 1/4. Okay. If we had like a -1/2, we would flip it and make it positive. If we would, so -1/2 and 2 are negative reciprocals. So those slopes are perpendicular. Let's just do one more for funsies. Let's say we had 3, then the negative reciprocal or the perpendicular slope, we flip it and do the opposite sign. So in this case, it would be -1/3. All right, more examples. You guys can pause this and answer this question on your own and then come back to the answer. Welcome back. So our line has slope 5/4. What is the slope of the line that is parallel to our line? Well, if it's parallel, it has the same slope. So we can write 5/4. What is the slope of the line that is perpendicular to our line? Well, we're going to flip that 5/4 and we're going to change the sign. So -4/5. All right, let's do another one. Our line has slope 0. What kind of line is that? Go ahead and pause and see if you can answer these questions. Welcome back. So if our line has slope 0, that is a horizontal line. So what is the slope of a line that's parallel to our line? It has the same slope. And what is the slope of the line that is perpendicular to our line? Ooh, that's confusing. There is no inverse to 0. But what kind of line is perpendicular to a horizontal line? A vertical line. And what's the slope of a vertical line? Undefined. Perfect.